Hello, students. Have you ever stopped to notice the little bits of science that are happening all around you every single day? Well, today we are going to explore one such process. Something that feels like magic, but is actually just amazing physics. Let's start with something you see all the time. Your mother washes the clothes, hangs them outside to dry, and after a few hours, they're completely dry. So where did all that water go? It's almost like it disappeared, right? And here's another thing to think about. Imagine you're playing outside on a really hot day. You start to sweat. But as the sweat dries from your skin, you begin to feel a little cooler, a little more refreshed. Why does that happen? Well, believe it or not, the answer to both of these questions lies in the exact same scientific process. So, here's our plan to understand this properly. First, we'll look at these everyday mysteries. Then, we'll define what evaporation actually is. We'll also see what factors affect it and understand how evaporation cools us down. And finally, we'll have a quick summary and some very useful tips for your exams.
Okay, so what is this scientific process that makes water vanish from your clothes or your skin? Well, this process has a name, and it's called evaporation.
Now let's look at the scientific definition. The phenomenon of change of a liquid into vapors at any temperature below its boiling point. Now this last part is the most important part to remember, below its boiling point. This means water does not have to reach 100 degrees Celsius to turn into vapor. It can happen at any temperature.
Now, it is very important not to confuse evaporation with boiling. They are two different things. Boiling happens to the entire liquid at once. We call it a bulk phenomenon, and it only happens at a fixed temperature, the boiling point. Evaporation, on the other hand, only happens at the top layer of the liquid. It's a surface phenomenon.
So, how does this happen at the particle level? Well, you can think of it in 3 simple steps. First, we know that particles in a liquid are always moving around. They have kinetic energy. Second, some particles at the surface have a little more energy than the others. With this extra energy, they are able to break free from the forces that are holding them in the liquid. And third, as these high-energy particles escape one by one, the liquid slowly turns into vapor.
So we know evaporation is happening, but does it always happen at the same speed? Think about our clothes example. Why do they sometimes dry in 1 hour, but on other days, they take the whole day? Well, let's look at the factors that affect the rate of evaporation. There are 4 main factors that we need to understand. They are surface area, temperature, humidity, and wind speed. Let's discuss each of them one by one. The first factor is surface area. Now remember, we said evaporation is a surface phenomenon. So it makes sense, if you increase the surface area, you increase the rate of evaporation. This is exactly why we spread our clothes out wide to dry. If you just leave a shirt in a crumpled ball, it will take a very long time to dry.
Second is temperature. We all know that clothes dry much faster on a hot, sunny day. Why? Because when you increase the temperature, you give more kinetic energy to the particles. With more energy, it becomes easier for them to escape from the surface and become vapor.
Our third factor is something called humidity. Humidity is simply the amount of water vapor that is already present in the air. Now, if the air is already full of water vapor, like on a rainy day, it can't hold much more. This is why on a very humid day, evaporation is very slow.
And finally, we have wind speed. Clothes always dry faster on a windy day, don't they? This is because the wind helps to blow away the water vapor particles that are near the clothes. This makes room for more particles to escape from the liquid, and that speeds up the whole process.
Okay, now we come to the most interesting effect of evaporation, its cooling effect. This is the science that finally explains why we feel so cool and refreshed when our sweat dries.
So how does this cooling actually work? It's simple, really. For a particle to escape the liquid, it needs energy. So where does it get this energy from? It absorbs the energy from its surroundings. Now, when the surroundings lose energy or lose heat, their temperature naturally drops. And this drop in temperature is what we feel is cooling. This is exactly what happens when we sweat. The particles of sweat on our skin need energy to evaporate, so they take that energy, that heat, from our body. As our body loses heat, we feel cool. It's like our body's own personal air conditioner.
And this is also why we are advised to wear cotton clothes during the summer. You see, cotton is a very good absorber of water. It absorbs our sweat and exposes it to the air over a larger surface area. This helps the sweat evaporate faster, and that in turn helps to keep our body cool.
A wonderful example of this from our own homes is the earthen pot, or the matka. A matka has lots and lots of tiny pores on its surface. Water seeps out through these pores and evaporates from the outside surface. To do this, it takes heat from the water that's inside the pot, making that water nice and cool.
If you want to feel this effect for yourself, just take a drop of nail polish remover, which has acetone in it, and put it on your palm. It feels cool almost instantly, doesn't it? That's because acetone evaporates very, very quickly, and as it does, it pulls heat energy directly from your skin.
All right, let's quickly summarize all the important points we have learned today about evaporation.
So let's recap. First, evaporation is the change from liquid to vapor at any temperature below the boiling point. Second, it is a surface phenomenon. Third, it is affected by 4 factors: surface area, temperature, humidity, and wind speed. And finally, and most importantly, evaporation always causes cooling.
Now, for your exams, if a question asks why evaporation causes cooling, this is the perfect answer. You must mention that the particles absorb energy from the surroundings to overcome the forces of attraction. This energy that is absorbed is called the latent heat of vaporization. And because the surroundings lose this heat, they become cool. This is the complete scientific reason.
So, now that you understand the science of evaporation, I want you to look for it all around you. It's happening everywhere, from the great water cycle that gives us rain to the simple act of cooking in your kitchen. Just observe and see how many more examples you can find.